Okay. So starting off here, 1a, I tell you that cos theta equals minus root 3 over 2. How many solutions here?
2.
How many? 2. 2. Shh, quiet time now. Why does this have 2 solutions? Oh. What do? You look at the number in front of the angle. What's the number in front of the angle here? 1 theta, and then you double it. So you have 2. So calculator in radian mode, and then cos inverse minus root 3 over 2. So your first answer is 5 over 6 pi. But how do you get your second answer for cosine? Come on, how do you get your second answer for cosine? Nope. Nope. Yeah, 2 pi minus the first answer makes the second answer for cosine. So you have 5 pi over 6 or 7 pi over 6.
But it says within the range of only 0 to 2 pi.
Oh, 0 to pi, does it? Ah, okay. So remember our steps. Yeah. I've done the I, that's the inverse, yes? I've made the extra answers, that's it there, yes?
How did you get the 7 over 6?
2 pi minus the first answer.
Okay.
I made the extra answers. Is there any simplifying I need to do here?
Yes.
Well, no, because it's just theta. It's not like 2 theta plus 5, you know? So this is already done. And then fix. So I need to make sure my answers are between 0 and pi. Is this one between 0 and pi? Yes. Is this one? No. So I can add or subtract 2 pi to it, but it will do no good here. Because if I add 2 pi, what will happen? It'll be too big. Yes? And if I take away 2 pi, what will happen? Yeah, it'd be negative. So in fact, we cannot fix this. So this one is rejected. This is rather unusual for us. We've never done a problem yet where we had to reject an answer. And the reason it happened here is because their range is so small. Because normally what's our range here? 0 to 2 pi. Yes.
Did you get 5 over 6 pi?
Continue, Talon.
Minus root 3 over 2.
Yeah? Yeah.
I didn't.
Is your calculator in radians mode? Do you have a calculator, Amjad?
Yeah.
And is it in radian mode? No. Don't. Is it in radian mode?
Yeah.
Are you sure?
2.6.
Now it is, huh? Guys, if your answer doesn't match my answer, before you say anything, just check that your calculator is in the right mode. Okay? So you need radian mode for this.
Sure.
Yes.
The 5 over 6 pi is 2.6 and the other one's 3.6. So
This one here is 2.6, and this one here is 3.6 or whatever. So what's your question? What are you asking me then?
so why did you reject that? And that's also it.
No, this one is bigger than pi.
Pi 3.1.
Oh, okay. Thank you.
Yes. Okay, going on to B now, right? Yes?
Yes.
Okay. Okay, I'll redraw the triangle. Oh. So this angle is 40 This angle is 59, so tell me using your calculator please what this angle is.
81.
Great, 81. This side here, this angle here is 46, and this side here, 7. And any other info? No. Oh, 9 here. Okay. Part 1. What's the angle P or Q? Well, we actually have that, don't we? Yeah, P or Q equals 81. Part 2. What is the length of QR? We need to use the sine rule here, I believe.
Yes.
So if we call this x, and don't forget to switch your calculator to degree mode now.
That's right.
Yeah. Degree now, yes. Shh, no talking. X over sine 40. X over sine 40 equals 9 over sine 81. So then just bring the sine 40 up here. Yep. Okay, 3. Find the area of PQR. So how do I find the area? It'd be a half times, what number? 9, yep, times 5.857 times sine of what angle? 59, very good. Oh, actually, these are in meters, so that's meters, and then that's meters squared. Okay. I think this is probably the best trigonometry question you could get in the exam, because I can't believe I'm nearly finished this one now. Find the length of QS. So what rule would I use for QS? Not sine rule. I'm going to use cosine rule. I'll call it y. So you get y squared equals, if you look here, y squared equals x squared plus 7 squared minus twice x times 7 times cos 46. What's the x here? There it is. Isn't that it there? Yeah. So y squared equals x squared plus, what's the other side? 7 squared minus twice x times 7 times cos 46. So you get yeah, don't forget to square root it.
Oh, yeah.
I think I did that okay, yeah?
I squared it and this.
Let me double check, sorry.
She got 10. Everything got 10.
It's 46, isn't it? Yeah, no, 8.67 after you take the square root. Yeah.
I did 5.85 and my answer is 10.
That's there is something wrong.
You did 2 decimal places?
Yeah.
I did 857.
And you did 3 decimal places. It seems like a big difference between 2 and 3. Joseph,
1 second.
what did you get?
I got
I
5.
used a different method. I got 5.12.
That's what I got.
Yes, then just
Did you all, you,
Yeah, it's exactly the same thing.
exactly the same as this?
Yeah,
Yes.
but, yeah.
And your calculator's in degree mode?
Yeah.
Alright, let's do this one more time. 5.857 squared, yes? Plus 7, no, let's do this together. Plus 7 squared, yes? Minus twice times 5.857 times cos 46. So I got 75.167, and then I square root that answer, and once again 8.67.
How did you get 75?
Yeah, it's 27.
You get 26.343
Yeah.
something.
Yeah, I got 5.1.
Is your calculator in the...
Sure is. This is weird.
56.
Oh, bracket. That had the between brackets, the same answer.
Like yours?
This is weird. My calculator's broken.
Should have taken this.
No, I typed the same thing in on both.
Oh, beautiful.
Stephen, why you...
Shh. Oh, I don't know. Twilight Zone. Okay, so 5.13. Okay, cool. Right, that's first one done.
Could you explain the last part?
Which part of the last part?
Yeah, that, why do you explain?
Oh, well, I just put the square root over this answer on the calculator as well. So the calculator should give out 5.13. I use the cosine rule here. Yes? Okay. Number 2 now? Okay. How do we change 143 degrees into radians? Pi over 180. Right, so what do you get there? Doesn't simplify. Usually they're quite happy to have this in decimal places in the exam, unless they tell you not to. So this would be 2.495. So if I did round off, it'd be 2.5.
It's just one.
You got that? Okay. B. Well, we've seen these typed before, haven't we? And then here to here, that's 40. And we want the height here. And my hint for these is it's always helpful to find the x here first. Okay, different color. So let me put in all the angles we can find. So this one here would be 180 minus 27. So what's that? 180 minus 27.
Double 53.
And then 153 plus 21, that's 175. So that means this here, again, problems with the 4 and the 5s, yep. This one here would be 6. This is 27, this is 90. So if you add them together, that's 117. So if you do 180 minus 117, we can get this angle here.
63.
Now, what rule can we use to find the x? We can use the sine rule. So we can say x over sine 21 equals 40 over sine 6. X over sine 21 equals 40 over sine 6. So we get x equals 40 sine 21. Now actually don't type it in just yet, because it'll be a tiny bit more accurate if we put it in at the very end, okay? So we know what x is now, right? So we can pretend as if x is a number. Now if I know x and I want the h, what's the name of this side in this right angle triangle? Hypotenuse. In this one? Opposite. So which do I use? Sine, cos, or tan? Sine. So sine 27, what will that equal? H over x. Yeah, and what do I want here? The h or the x, what do I want? H. H. So I bring the x up here and I have my answer. H equals x sine 27. But you know what x is? It's 40 sine 21 over sine 6 multiplied by sine 27. I'll wait for someone else to get the answer as well. So tell me what you got here for H. Error. Oh dear. Yes? 62, yep.
25.
25. If I round it off, it'd be 0.3 meters. Okay. Well, do you need me to go back to this? Yeah. Yes? You need to go up? I don't think that, I think it's only the sine rule up the top there. It was x over sine 21 equals 40 over sine 6. Okay. Okay, see now. We have to find A, B, C, D. What one do we find first? Now hang on. Listen and focus. Yes, we find the A first. What is the height of this graph? Look at it. What's the height of this graph?
3.
No, the total height. 4, because it goes from -1 to 3. So it's 4 units tall. How tall is a sine graph normally? 2. So this graph is twice as big. So therefore A is 2. Next one we find is the D. If I had 2 sine, what would be the max and the min? -2 to 2. But this graph goes from -1 to 3. Therefore, it's been lifted 1 unit, yes. next we get our b, and we can use our formula for b. What's the formula? What I said was 2 pi over the length. Now this graph starts at 0 and finishes at 10 pi. So how long is it? 10 pi. So b is 1 over 5. So we're in a position to say y equals a sine b theta plus c plus d. And the last thing to find is c. And how do we find c? We use a point. What point should we use here? It looks like the easiest point to use there is 0, 0. You see it goes through 0, 0? So if I use 0, 0, I get 0 equals 2 sine c plus 1. So take the 1 over, minus 1 over 2 equals sine c. So c is sine inverse minus 1 over 2. Sine inverse minus 1 over 2. If I keep it in degrees, which I shouldn't because it's in radians. Yeah, but it's in radians, so minus pi over 6.